Welcome to class. Today, we're going to start talking about solving linear non-homogeneous equations, and the first method we're going to see to do that is the method of undetermined coefficients. Let's get started. To motivate, let's start by considering the example y double prime minus 10y prime plus 25y equals 30x plus 3. And recall from our previous videos that all linear equations have general solutions, and the form is the complementary solution plus a particular solution, where the complementary solution we know how to do as of recently. If you watched the last few videos, we talked about how to find solutions to homogeneous equations, and the complementary solution is just the general solution to the complementary equation, or in other words, if I just write it as a homogeneous equation. So it's the general solution to y double prime minus 10y prime plus 25y equals 0. Now, if you haven't seen the previous videos, I'm going to ask you to go watch those now, because what I'm about to do will make no sense otherwise. I first write the characteristic polynomial, lambda squared minus 10 lambda plus 25, and its roots end up being, well, only -5, or repeated twice. When I set this equal to 0, that is. So what this tells me is that the homogeneous equation has the general solution, or equivalently, our problem has the complementary solution, that yc of x equals c1 e to the root, by root I mean lambda, x, plus, since it repeats, I need to tack on a power of x this time, e to the -5x. Now all there is left to do is to find that particular solution, but it turns out that's usually going to be the hard part. The method of undetermined coefficients is one of the most straightforward in terms of workload methods that we have, but it can be finicky. In this example, though, it should be pretty well behaved, so that's why we're starting here. What I'd like you to notice is, at the moment, the information we have about our general solution is in terms of exponentials, and we expect to see that because we have a linear equation. However, nothing about this general solution is giving me the linear terms that I see over here. In other words, I would expect to see some linear function of x, or maybe something like a constant times x plus another constant. If this is the solution, I see I should be left over with a linear equation. Where is the linear piece? Do you notice? I have a good idea about what the form of my particular solution looks like, but its coefficients are undetermined at the moment, hence the method of undetermined coefficients. Let's see how we determine them. I'm going to need a little bit more room to work from here, so I just condensed our thoughts so far. That the complementary solution we just found to be c1 e to the -5x plus c2x e to the -5x, and we are supposing that our particular solution must be a linear polynomial if we're going to end up with one on the right-hand side somehow. Recall that the particular solution is itself a solution to the equation. It's just a portion of the general solution that defines all solutions. So the particular solution is also a solution, meaning that when I plug it into the left-hand side, I should get the right-hand side. So let's see what happens. Well, with this format, I know that y prime, or yp prime I should say, is going to equal a, and yp double prime is 0. So substituting that in to my differential equation, I see that yp double prime minus 10yp prime plus 25 is, well, 0 minus 10a plus, oh, excuse me, yp, missed that in there. That makes a little more sense, plus 25 times this guy. And to make it a little bit more clear, here is yp prime, and here is yp. But what I know is that that should equal 30x minus 3. How do I determine my coefficients then? Well, do you notice I have terms with x's and terms with x's? I have constant terms and constant terms. When all is said and done, if yp is a solution, those had better match. So let's clean up this equation first of all by grouping up all of my terms with x's. I have a 25a, and I'm going to write it this way so that it's easier to see in just a second. 25a times x. And then my constant terms, I've got a negative 10a, and I've got a 25b. Oh, b. And those should equal 30x plus negative 3. And now what I want to do is choose a and b to ensure that the coefficients on the x's match and ensure that the constant terms match. Notice I have two constants, but out of this I can build two equations. One of those equations is that 25a should equal 30. The other being that negative 10a plus 25b should equal negative 3. Solving this red equation for a, I get that a is 6 over 5. Solving this blue equation for b, I get b is 3 over 5. That's, of course, after plugging in a. So, all in all, I now have determined the coefficients on my particular solution. I know that yp of x is 6/5 x plus 3/5. And now altogether I can solve this non-homogeneous differential equation because I know the general solution is the complementary solution, c1 e to the negative 5x plus c2 x e to the negative 5x plus the particular solution, 6/5 x plus 3/5.